Hello everyone and welcome to my channel. This is Sohini from South Bay, California, and I welcome you today. So today, for everybody who's tuning in for the first time to my channel, this is where we talk about everything AI and machine learning. We start from internships, we get into hands-on concepts and tools, we sometimes talk about job markets and trends, and again, we get into research, the whole shebang. So if any of this is of interest to you, please give this a video a thumbs up and subscribe to this channel. So today I wanted to release this special video, and this is very much like a holiday treat or for anybody who is an enthusiast in the field of artificial intelligence and machine learning, and if they want to figure out if this is really for me or not. And if you are one of those people, I will show you 3 very relevant AI experiments, and if you're wondering what is going to follow in this video, this is the snapshot.
And I'm, moving my, let me do a box.
So here is today's video.
So this is the first experiment, which is called Teachable Machine, and again I will be sending the link for this down below, and again all of this is you'll find the details about getting the code, and if you launch the experiment, all of the details and the documentation of the people who created it is in the website itself. So please go ahead and try it out. What I wanted to show you is what this system can actually do. So the Teachable Machine, let's try the post project. And what the post project does is, again, this is very simple concept of machine learning. And what I need to do is I need to create 2 different classes of very different samples. So the first class would probably belong to postures or poses of one kind, and class 2 will be poses or postures of another kind. And then we are going to be teaching this automated system to differentiate between these 2. So this is an example of supervised learning. And then we will see for a test sample how this taught or trained system or trained machine learning system is capable of saying, does it have pose of class 1 or does it have pose of class 2? So this is very basic understanding of how a typical supervised learning machine learning system actually works. So let's look at that in action, and then I will tell you the underlying algorithms behind it and some ways to utilize this or morph this whole learning experience towards your own examples. So let's start with generating some test cases. This is actually training data set, and you're generating training data set on runtime. So let me first have sitting down poses, and you will see that this system tries to create stick figures, and this is trying to generate poses out of the stick figures that I have. And again, it already has a preloaded model in order to do that. So let's start with sitting poses, and then we will do some standing poses. Okay, so I'm holding to, I need at least 30. So I have 68, that's good enough. Now let's go to generating pose type 2. And here, let me stand up, maybe trying to do a little more dancing poses, where you always see my hand. Okay, so you see, we have some sitting down poses and then some standing up poses. And now let me say, train my model. All right, so I wanted to show you what this training model actually did. So if I open the advanced version, now I can actually see under the hood what are, how many epochs it ran, and how the training and the test accuracies changed, how the loss functions varied over the 50 epochs. And here you could have actually even changed the learning rate, the batch size, and of course the number of epochs. So for those of you who are getting into machine learning for the first time, don't be nervous about what these terms even mean. What it means is it's fairly easy. Epochs is the number of iterations or number of times you actually feed a certain number of data, and in this case the number of data is broken into batches of 16 images per batch, and then you actually feed it to the machine to churn it. So think about it as a batched processing system where you batch 16, 16 batches of images at a time, and you just continue this process for 50 times. And the learning rate, it is just another parameter that helps you reach the optimal, the global optimal, which tells you that this is the final model, and that can then generalize across your test cases. And now let's see what it has actually learned. So if I'm taking the input from my camera, you see that while I'm sitting, it's giving me the stick figure around my shoulder, and it keeps saying that this is a class 1 image. So class 1 was the sitting down poses, remember? So while I'm sitting here, I'm doing anything, it goes on saying that it's class 1. Notice that if my face is covered, or if my body is covered, then it doesn't know what to do, and it starts predicting class 2, because class 2 was more of the standing poses. But now if I stand up, and if you see more of one arm, and if you see more of the dangling poses, you see it's saying it is class 2. So there are two different ways of estimating this stick figure. You see these landmarks that the system is detecting. There are two ways of doing that. One is an unsupervised, where you figure out structurally that yes, this is around where a face is, and then you start putting the landmarks. So you see landmarks is 2 ears, 1 nose, and 2 eyes, and these are the landmarks for detecting my face. And then if I stand up, you will see that there are more landmarks around my shoulders, and these are the landmarks to mark that this is my hand. And these landmarks will then be used to see that if I'm dancing or if I'm just sitting down and my face is showing. Okay, so in this particular experiment, this is more of a supervised learning case, where the computer has already seen, or the system has already seen, a significant number of faces, and it knows exactly where these landmarks lie. So it is very easy to quickly figure out where the landmarks are for a particular face and overlay them. And this exact concept we have actually used for pedestrian intention prediction in one of our cases, where what we saw is if you just take the picture and try to predict what the pose is, you may sometimes have a lot of false positives. But if you overlay landmarks, and if you overlay the stick figure on top of the original image, your chances of getting a false positive are actually low. So if you want your detection or your prediction system to get more and more accurate, it is a better exercise to overlay the original image with stick figure images. The second experiment that I wanted to show you is called quick draw. And again, here what it says is the system tells me to draw something. It's like draw an elephant under 20 seconds. So and again, I am an extremely bad drawing person. So let's say I try to do something like this. It says it's an elephant. So the system knew that it's an elephant. Now let's say for a wine glass, and it says it's a wine glass, right? And then if it's a hammer, let's see if I can do this. But it already knows it's a hammer because it has a group of images it's pulling from. A sea turtle. Okay, this one's gotta be hard. Okay, and these were all the examples that I had. So the system was able to guess correctly. Now let's see if I had drawn something else. So why was it able to say that this is an elephant when I drew it? It's so horribly wrong. So you see in these cases, people who had drawn the system, whenever it has seen elephant, it had this trunk sort of feature. You see the underlying it is most similar to this trunk sort of feature. So it was most similar to an elephant. It was secondary similar to a helmet, and it's third similar to a stake. So this is still supervised learning, but in these cases, whenever you're trying to do pattern recognition, I wanted to give you the underlying algorithm. The underlying algorithm in this case can be recurrent neural network. While I explain it, so if I'm making a street light, you see I'm making a continuous line, right? So all of this is becoming an input at a time t is equals to 0, and based off of where my line is at the next time instant, it is generating some changes in the hidden layer, and the hidden layer across the different time instances can actually communicate with one another in order to then generate the final outcome. So a recurrent neural network, if you have your inputs going like this, and then a recurrent neural network would have a lot of hidden states, and then you have your output as your y. And but then what will happen is then there are a lot of the hidden layers can actually communicate with one another, and this y can also be feeders into them. The third experiment that I wanted to show was AI duet, and this has to do with music. So what we do in this case is this will give you a piano-like structure, like so. And what you do is, if you start playing some sort of keys, the system will learn what order you are playing, and this yellow, whatever you see, is actually the system figuring out patterns. And so it's figuring out patterns from your own playing, and it is like somebody else. This system is now becoming the duet that is playing with you. Notice one thing, that it takes a certain amount of time for it to figure out the pattern, but once it has, it then tries to interlude them. So of course the keys that you are playing, then they are not played, but everything else, it will try to figure out snapshots from intermediaries and then try to put those fillers in. And again, the underlying concept here is still the same. It's still recurrent neural networks, or you can say it's bidirectional hidden Markov models as well. These are the two classes of models. What they do is they take history into consideration to look at what is going to be predicted in future, and then they look at the future value as history, and then they try to predict the past, right? That's why the name bidirectional. So you take the history to predict the future, you take the future to predict the past, and based off of this you learn the underlying context or the pattern, and based off of this pattern then you can start generating music of your own. But of course, if I am playing a particular key, the system will not use that particular key. It will use, or it will bank on some other key to play at that particular point. If you want to know about sequence learning models, that's the way to go. Or if you just want to play piano with an automated system on the holidays, this is another way to stay busy. Hope you enjoyed these experiments, and if you do like them, if you want me to cover more, please do let me know in the comments below. Thank you. Have a wonderful holiday.